This is Dr. Holt. This video is on an impulse type problem. Here I have a 73 kilogram man standing on a platform, steps off and begins a 3.8 meter high diving platform. So I'll make this 3.8 meters. The man comes to rest 1.9 seconds after. That's after reaching the water. So down here is going to come to a stop. We want to find the average force. Alright, now what you don't want to do in this problem is to think that the only force you're going to have is what's going to change the impulse. You've got to consider what's taking place here. So what I'm going to do here is draw a free body diagram of what's happening in the water. I'll have the diver. Get rid of this real quick. This coming down. This will be mass times gravity coming down. Now here, if the come to a stop, then I must have a larger force going back up, because if I enter the water I have a velocity, and now down here where it stops the velocity's gone to 0, so I know I have a force going back, which means I have an acceleration going back. So this will be the force, put that in black. This will be the force being done by the water, and this will be mass times gravity, or we can put 73 times 9.8. Alright, so now let's find out what the velocity is going to when the man hits the water. Now we could do this with the kinematic equations, or we can do it with just potential kinetic energy. So I'm going to do it with potential and energy. So I can say that the potential energy initial plus the kinetic energy initial must equal to the potential energy final plus the kinetic energy final. Now I'm defining final as when the band is just touching the water right here at this location here. Now we know when he's stepping off here, his kinetic energy has gone to 0, and we know here that the potential energy has gone to 0. So we can just solve this by using the mass, 73 times 9.8 times the height, which is 3.8, must equal to 1/2 times the mass times velocity squared. Now our 73's will cancel out, so now we can say that velocity is going to equal to the square root of 2, bring the 2 up, times 9.8 times 3.8. Okay, grab the calculator, run that real quickly. 2 times 9.8 times 3.8. Take the square root of that. And I get a velocity of about 8.63 meters per second. Okay? Alright. So now let's find out what the momentum is going to be here. So we'll make this 1, and what's the momentum going to be here? Now we know here that our momentum has gone to 0, right? Because we've stopped, our velocity is 0. So we know that the change in momentum, change in P, is always going to be the final momentum minus the initial momentum. Alright, so final momentum, again, is going to be equal to 0. Now remember, this is a vector quantity. So we can set that up as 0. And now when I'm coming down, I'm going to minus. And now I'm going to have minus momentum when I enter the water, which is going to be the mass of the individual, which is 73, times minus the velocity, which we said was 8.63. Okay, we'll run that number real quick. Take that number there. Change it. Okay. 8.63 times 73 gives me a value of about 630 approximately. Gives me 630 kilograms times meters per second. So that's the change in momentum. Now, what we want to do here is, we know this force is going to be larger. All we want to do now is sum our forces in the y direction. When I do that, I will get minus 73 times 9.8 plus the force the water is pushing up. Now that's going to always equal to the net force, or equal to mass times acceleration, which is the same thing as the net force. So we'll find out what the net force is going to be by using the impulse, because we know the change in impulse is always going to, change in momentum is going to equal to impulse. So we take the value we have here, 630. We're going to set that equal to impulse, which is force times time. So that's going to be force net. And I think we're given a time value of 1.9 seconds. Okay, but again, we know that net is equal to this. So we take 630 is equal to, in parentheses, minus 73 times 9.8 plus the force of the water, all times 1.9. Okay, divide by 1.9, that's going to give me 630 over 1.9. We'll add this to both sides. Let's see here, say 3 times 9.8. That's going to equal to the force of the water. Run that number real quick. 630 divided by 1.9 plus 73 times 9.8 gives me a value of approximately 1,047 newtons. And that's going to be the force that the water is pushing back up on the man to bring the man to a stop. Okay, so in this problem I've done several things. I've used the conservation of mechanical energy to find out what the velocity would be when the individual just touched the water. Then I've gone back and used the conservation of momentum, set that equal to my impulse, and from that I was able to solve what the force would be. But remember, when you do the summation of forces, you just can't say, wow, it's just going to be force times time. The force is going to be the net force, so you need to find the net force every single time. And by doing that, just take the summation of forces, set it equal to your net force, which is equal to mass times acceleration. All right, best of luck.